Good afternoon, everyone. Today, my group and I will be presenting about adopting TOGAF to address AI challenges in the manufacturing industry. We will start off by giving an overview of AI in manufacturing, a brief explanation of TOGAF and the challenges in AI. Then, we will introduce our research question and how TOGAF helps to address the challenges identified, followed with a list of implementable recommendations. AI is essential for organizations in the manufacturing industry to achieve a competitive advantage due to AI's ability to innovate traditional processes. One of the highly demanded trends in the manufacturing sector is automation driven by AI, where machines or robots execute tasks without the assistance of humans. This is possible because AI adapts to the environment and learns from past patterns, then transferring those technical knowledge to the machines and robots for them to carry out tasks repetitively at an accelerated pace. Therefore, AI automation can increase the efficiency and effectiveness of a manufacturing process and eliminate redundancy. Predictive analysis, which addresses operational issues and supply chain disruption, is another major trend made possible by AI. According to reports, predictive analysis can help manufacturing processes increase accuracy by 10 to 20%. AI uses a large amount of data set to intelligently react to bottlenecks and provide suitable solutions. By anticipating demand, spotting obstructions, and eliminating interruptions, AI can improve and streamline the supply chains of manufacturers. Therefore, there are many benefits by employing AI in manufacturing, as it can lead to an increase in revenue and decrease in cost spendings. TOGAF is a widely adopted framework for enterprise architecture that provides a guideline of best practices to support businesses in creating an EA that is in line with their business strategies and objectives. It provides a structure that ensures everyone is working towards the same goal. TOGAF has many benefits such as process completion, vendor neutrality, layers interaction, and alignment with industry standards that makes it suitable to be used in a manufacturing research. There are two parts of TOGAF that are focused on it in this presentation. The first one is the architecture development method, which is the core of TOGAF. It offers a 9-phase systematic approach for developing enterprise architecture, each of which has its own set of deliverables. By following this approach, organizations can achieve an effective EA that improves agility and adaptability. Reference models are used within the ADM to serve as a foundation and guideline for different architectural domains, such as business, architecture, application, information, and technology. The models encourage uniformity, interoperability, and effectiveness, providing architects a level of standard so that they can consistently design the enterprise architecture.
Thank you, Megan. Based on the literature review we did, there are 5 main challenges in accommodating AI. The first one is interoperability and technological infrastructure. Interoperability in IT systems refers to the ability of different systems to exchange and interpret data independently. Deploying advanced industrial systems with AI poses a challenge of ensuring interoperability with existing systems due to the need for high levels of data interrogation and interpretation. Availability of proper IT infrastructure is crucial for ensuring security, quality, and reliability of industrial AI solutions. The second challenge of data quality. In manufacturing, high-quality data are crucial for optimizing operations, particularly when AI is involved. Low data quality could lead to inaccurate and biased decision-making ability of AI systems. The third challenge is data privacy and security. AI analyzes large amounts of data, which may include confidential information such as trade secrets and personal information. Vulnerabilities in the cybersecurity of AI will lose their trust and cause significant financial damage to companies. The fourth challenge is lack of standardized approach. For now, most of the manufacturers don't have a standardized roadmap, which could give them guidance about how to integrate AI into their existing business practices and processes. This is significant as they may lose the opportunities to reap the benefits of adopting AI, which is highly correlated with the data-driven digital transformation and Industrial 4.0. And the last one is cost and resource constraints. The implementation of AI in the manufacturing industry requires significant investments. Many research papers identify the opportunities and challenges of adopting AI in the manufacturing industry, and enterprise architecture could be the solution to mitigate the challenges posed by the integration of new technologies. However, limited research exists using enterprise architecture to address these challenges in AI adoption within the manufacturing industry. Therefore, our research question is, how does the manufacturing industry adopt TOGAF to address AI challenges? Thank you, and over to Manhu.
Thank you, Tina. Let's talk about overcoming interoperability and technological infrastructure challenges. So, when integrating AI into the existing technology infrastructure, it is unavoidable that we have to integrate different operating systems, databases, and software. So, given this diversity, interoperability can be a reality only through standardizing the technical infrastructure and formats for data exchange and communication between different systems and stakeholders. Let's see how best TOGAF can achieve these objectives. So, in addition to the TOGAF general guidelines, business architecture phase of TOGAF can help manufacturing organizations to have a clear picture of the stakeholders involved and in the business processes, how information is exchanged between the business processes and stakeholders. This will provide a solid basis for standardizing the exchange of information and IT infrastructure, enabling the effective implementation of AI. So we all know that AI is an emerging technology with unpredictable developments in future. Therefore, we should ensure that flexibility is there to adopt emerging AI technologies. So in this background, it would be essential to maintain interoperability between the existing information systems within the organizations as well. So during phase C, TOGAF provide guidelines to ensure intersystem interoperability, and also the TOGAF tools like business information interoperability matrix, the information systems interoperability matrix. So they will help keep track of inter-stakeholder information interoperability as well as intersystem interoperability requirement. So in overall, implementing AI requires robust technical infrastructure that can support interoperability across various systems. So using TOGAF ADM as a guideline, manufacturers can overcome the technological infrastructure and interoperability challenges in adopting AI. Then let's talk about the data quality challenges in manufacturing. Production of high quality data is a prerequisite for integrating AI into manufacturing. Let's discuss how best TOGAF can help manufacturing organizations overcome this challenge. In order to address the challenges of data quality and to ensure that the data is of good quality for AI to function, TOGAF can be applied as an approach to strengthen the enterprise architecture. During the business architecture phase of TOGAF ADM, the requirements for data quality and how AI systems would utilize the required data to carry out manufacturing processes must be clearly identified. And also, the strategy should be aligned with the company's business objectives to attain high data quality for accurate functioning of AI. During the information systems architecture phase, the types of sources of data needed to support AI must be defined with a focus on data architecture. By outlining the target data architecture, manufacturing organizations can determine whether the existing data quality is within the targeted quality and whether it complies with all AI requirements. During the technology architecture phase of TOGAF ADM, organizations should examine the existing infrastructure of the company to ensure that it is up to date with the existing technologies to support AI and data processing. This is very important because these technologies store, analyze, and process data which will have an impact on the data's quality. By adhering to these guidelines, manufacturing data will experience improvements in accuracy, timeliness, and consistency. Thank you very much, and over to you, Tomahiko.
Data privacy and security challenges can be addressed by developing data architecture in TOGAF ATM Phase C with reference model designed by Zorilla and Leibniz. This model is dedicated to data governance to address Industry 4.0, where large amounts of data are processed by AI. The red boxes in this model are particularly related to data privacy and security. Firstly, governance and stewardship clarify who is responsible for the data input to AI. Secondly, classification and metadata provides detailed categorization of data to decide security levels and help select which data should be input to AI. Thirdly, data security supports developing security policies customized for various suppliers. Finally, data lifecycle enables lifetime protection of data. These are representative benefits. This reference model offers many other benefits, so transparent and reliable data governance will be achieved by using this model, and data privacy and security challenges will be addressed. Next challenge is lack of standardized approach. Gradually developed a 6-step roadmap based on TOGAF ADM, which provides a comprehensive approach to deploying AI. Step 1 is initialization. This corresponds to the preliminary phase. This step identifies the organization's scope, capability, constraints, business goals, and drivers. Step 2 is purpose defined and readiness assessed. This step defines purpose of integrating AI into the organization and assess its readiness. Step 3 to 6 are current states defined, target states defined, gap analysis, and roadmap developed. Step 3 and 4 define the baseline and target architecture when deploying AI. Step 5 analyze the gap between baseline and target architecture, considering AI deployment. Step 6 determines the projects and priority order for those projects when integrating AI systems. This roadmap can provide a standardized approach for manufacturing organizations to integrate AI systems. So lack of standardized approach would be addressed by this roadmap.
Thanks, Tomohiko. Now let's discuss how different phases of the TOGAF ADM can address costs and resource constraints in AI adoption. In the preliminary phase, we identify detailed resources for architecture governance, aligning resource planning with strategic goals and budget constraints. In phase C, data architecture defines key data types and sources for AI implementation, optimizing software costs and ensuring efficient data processing. And in phase D, technology architecture delivers cost-effective hardware and software solutions, addressing stakeholder concerns about costs and maximizing investment value. In phase F, migration planning estimates resource requirements, initial costs, and provides a resource allocation plan, enabling effective budget allocation for AI adoption. And lastly, phase G, implementation governance develops an implementation plan and a maintenance strategy, ensuring the availability of necessary resources and skills throughout the AI implementation lifecycle. In addition to these ADM phases, effective stakeholder management is crucial. Engaging with powerful stakeholders increases the chances of securing the necessary resources for AI implementation. By combining the ADM phases with stakeholder management, we can successfully address cost and resource challenges in AI adoption. In conclusion, the adoption of AI in manufacturing offers numerous benefits, including enhanced operational efficiency, improved quality control, and cost reduction. As highlighted in the table, the TOGAF ADM phases provide a structured approach to address specific challenges associated with AI implementation, such as interoperability, data quality, privacy, standardization, and cost constraints. However, it's important to note that AI adoption is an evolving field, and further research is needed to explore recent advancements and emerging challenges. One such area of exploration is the ethical concerns surrounding AI implementation in manufacturing. Understanding and addressing these concerns will ensure a comprehensive and responsible approach to AI integration. By leveraging the benefits of AI, utilizing the TOGAF, and conducting ongoing research, manufacturing organizations can stay at the forefront of technological advancements, drive innovation, and achieve sustainable growth. That's the end of our presentation. Thanks for listening.